Okay, now likewise, we have the row vector, que when you talk about vectors, que at least one dimension es 1. Entonces es, suppose 1, 2, 3, pero in that direction. This matrix contains only one row, 1 by 3 column. Okay, entonces now the operation that we are doing with the matrix is different operation. For example, addition, subtraction, multiplication by a scalar, multiplication in between the matrix, and the application of this. I want to explain that right now because it's too easy. Okay, suppose two matrices, A and B, same dimension, must be the same dimension. Si es different dimension, no. We cannot do at least addition or subtraction. Suppose I want to add in A plus B. It's too easy. You're adding entry by entry in the same position. 3 plus 5, 8. Minus 7, minus 2, minus 9. 0 plus 8, 8. 1 plus 3, 4. And 2 plus 2, 4. And 3 plus 1 and 4 again. It's a coincidence. Do you understand very well the addition? See, we have different, so now we cannot do that. If you try with the software indicate you, no, mismatch dimension, because it's impossible. And subtraction is exactly the same. Suppose A minus B, you subtract the entry by entry, 3 minus 5 negative 2, minus 7 minus 2 is positive 2, entonces es minus 5, 0 minus 8 es minus 8, 1 minus 3 es minus 2, 2 minus 2 is 0, and 3 minus 1 is 2. Okay. Everyone follow me, no? You understand easy where come from that number, right? Jenny says yes. Now, so you understand addition and subtraction matrices. Okay, now let's see multiplication. Multiplication, guys. Multiplication by a scalar. Multiplication by a scalar. I don't know why you cannot join. Try again. Okay, there's a multiplication by a scalar. What is that? A scalar. A scalar is a number, no matrix. So for example, si you have, you don't see the professor, Try to find in your own. Sorry. Okay, so now multiplication by a scalar. I say que scalar is just a number. Okay, no matrix, no only one. For example, 5, 7. And when you multiply 5 times A, it's a multiplication. 5 is a scalar multiplication by the matrix A. And you multiply any entry by 5. Entonces, 15, negative 35, 0, because 5 times 0 is 0, 5 times 1 is 5, 5 times 2 is 10, and 5 times 3 is 15. Do you understand multiplication by scalar? Likewise, for example, you have 3b, 3 times b. Entonces you multiply by 3 every element, every entry, que es the technical name of this, by 3. This is 15. This is negative 6. This is 24 because 3 times A is 24. 3 times 3 is 3 times B, 3 times 3 is 9, no? Is 9. 3 times 2 is 6, and 3 times 1 is 3. Boom. I suppose in the test, I asked you perform that operation. It's 5a plus 3b. It's a combination, it's summation of the matrix, but before you are doing the order of operation, is multiplication by the scalar. I did that. Now, final answer is you adding component by component, no? 15 plus 15 is 30. Minus 35 minus 6 is negative 41. 0 plus 24 is 24. 5 plus 9 is 14. And 10 plus 6 16. And 18. End the story. And the dimension stays the same, 2 row, 3 column. Do you understand very well multiplication by the scalar?
Yes.
Okay. Now, the most complicated part, in my opinion, is multiplication in between two matrices. So matrix multiplication. This is. Now I do multiplication in between two matrices. And this is not straightforward because some matrix multiplication. Suppose this example. Suppose one matrix is 2 minus 3, 1, minus 4, 7, and 0. By the way, the dimension is 2 by 3. If we have another matrix, is negative 1, negative 6, 10, 5, 8, and negative 2. Okay, the matrix 3 by 2. Okay, one more time, I analyze. And the first one, let me call C matrix. We have 2 rows, 1, 2, and 3 columns. Bam, bam, bam. However, in the matrix D, we have 3 rows, 1, 2, 3, and 2 columns, right? And now I want to do the multiplication C times D. And so now to apply the matrix multiplication, you need to match in perfectly the dimension. So dimension of C is 2 by 3. Dimension of D is 3 by 2. The important information is that number must be the same of this number. See, this is not occur, so it's impossible doing the multiplication. Okay, that is the number of column in the first must be the same of the number of row in the second. This is match the dimension. See, it's not the same. No. So you obtain a new matrix. Okay, I want to call E. And the dimension of this new matrix is the number that stay outside, 2 by 2. Okay, so we have one matrix that contains 2 rows and 2 columns. And let me call using the double subscript A11, A12, A21, and A22. So we need to find 4 numbers, only 4. What mean 1, 1, 1, 2, and 2, 1, and 2? Where's the double subscript? And the first subscript indicates us the number of the row that belong this element. So this element gets 1, 1. It's because it's located in the row 1 and column 1. This number is located in the row 1, column 2. This is row 2, column 1, and this is row 2, column 2. So basically, you need to find 4 elements. There are many ways to do the multiplication. I want to explain the classical way. For example, if you want, of course, everything so far that we covered today, we can do using GeoGebra. If you want, in the review package, we are doing everything using, but I want to explain the essential by hand. And when you understand the concept, well, okay, you save time and doing perfectly using software, no? To say now, what is the idea? What is the idea? To find A11. you multiply the entire row 1 and the entire column 1. So you multiply like that. Let me try to schematically represent like that. You copy 2, -3, 1, que es the row 1 and the matrix C, que by the way, this is 1 by 3, no? So I make a partition, no? Multiplication by a column vector que es -1, 10, and 8, que es the 3 row 1 column. Y es obvio que when you perform this multiplication, no problema, matching perfect the dimension 3, 3, and the answer is 1, 1, and 1, 1 is just a number, it's a scalar. And the multiplication is 2 times -1 is -2. Minus 3 times 10 is -30, 8. And the answer is -24. Okay, so this guy, I can erase this symbolic way, is -24. This is one possibility. There are a lot of possibilities you want to explain, but it's okay. Suppose I want to find A12. Well, it's similar. You multiply again this first row. No comma. No separate by comma. This is the notation without comma. Multiplication by now the second column, que es -6, 5, and -2. Okay, let me use in column to emphasize this idea. Now you multiply, let me use in another column, maybe green. You multiply this times this. Okay, so we have -12, -15, because -3 times 5, and -2 is -29. Okay, it's a coincidence in this example everything is negative. But no, not necessary. Do you follow me the order? I don't finish, of course, but do you understand the idea?
Yes.
Okay, now if you want to find A21, now I switching to the let me use in cyan color, maybe I like that. Okay, using hello, this multiplied by this. I don't see very well here. Okay, entonces es you copy. Not necessarily you can do mentally, but it's okay. -4, 7, and 0. Multiplication by row column vector, sorry, -1, 10, and 8, no? Is 4 plus 70, 7 times 10 plus 0, 74. This is 74. And finally, A22. We're using now the, maybe change the color, maybe gray color, multiplication this times this. So you multiply -4, 7, and 0 again by the column 2, the second matrix is -6, 5, and -2. We have 24 positive, plus 35, plus 0. The answer is 59. 59, positive 59. 59, and this is the multiplication. If you want, I can show you right now 59 in GeoGebra. You see the procedure. Guys, you don't need to do anything by hand in the test. But I would appreciate so much that you make a screenshot of the computation that you are doing in GeoGebra and attach to the test. Okay? I know that you are doing very well. You make a screenshot with the computation and attach for the test. Let's do it. Let's do it in GeoGebra. I open my own GeoGebra. You need to practice this, okay? I don't understand. You don't understand. You have the video, and the video is clear, the explanation, no? You imitate my work. Okay, so now let me share the screen for the GeoGebra now. There you go. GeoGebra Classic. There are several GeoGebra, but the version is powerful. I like so much is Classic. Okay, do you see? Do you see or no? Cool. Now you press this in the three horizontal line and select View. And View allow you, for example, in this problem, no graphic, no. CAS, que es Computer System Software, and Spreadsheet. Spreadsheet, remember, is the editor of the matrix. Okay. Entonces, let's do in the multiplication, que es the most complicated, because the addition and subtraction was extremely easy. Suppose we have here, let me take in my keyboard. Okay, we can use in the own keyboard of Desmos here. You click here, and you have keyboard. But I don't know why I like my own keyboard I have in my hand. Huh? Is 2, tab, -3, tab, 1. Enter. And -4, 7. Sorry. 7. And 0. And this is my first matrix. Of course, I put in the spreadsheet, but I need to create a matrix using that number. No? You select everything with the mouse. So you drag the mouse. Now selection, exactly the same you are doing in Excel, and create a matrix. And default, let me check if I type in well the numbers and making mistakes, another problem. If you want to change the name, I want to call this rename. This is a matrix. I call on the piece of paper capital C. Cool. Now in the other place, the place you want, not necessary continuation. No. You put in either way, -1, -5, no? -5, -6, sorry. Enter. 10. 5. Enter. Oh, take the mouse and click in the cell you want to type in. 8 and -2. And create another matrix. Select. Remember, you drag the mouse. You press the left click in the mouse. Relief. Press right click. And the right click you create what? Matrix. Bang. Let me check if the number is okay or no. Yes, it's okay. I want to rename. Not necessary. You working with the original number M1, M2, M3, M4 default. But I want to illustrate another possibility, no? Okay, capital D. Okay. Now, suppose I need to perform the multiplication. Multiplication is in the other line of this part is the, no, here, in the CAS, I suppose. You multiply C, capital C, time D. I press, the multiplication on the keyboard is the Shift 8, it's the after. You press enter, and you get the answer. -24, -29, 74, and 59. Cool. Super cool. No problema. Everyone follow me? Everyone is clear. Okay, I want to say now, I want to explain another thing. I want to explain, okay. Well, I want to explain another example. Another example of the multiplication because I want to explain a new idea. Look, whiteboard. Let me share whiteboard. Whiteboard, Microsoft whiteboard. Okay, do you see my whiteboard?
Yes.
Okay, now I want to erase. I want to do this example. It's super easy. It's super easy. You have the matrix E, is the matrix 3, 5, 1, 2. You have the matrix F, okay, the matrix 1, 2, 3, 4. Then I want to do the multiplication E, multiplication F, and F multiplication E. Yeah, I want us to illustrate you. Okay, the multiplication of the matrix is not in general commutative. So now, in general, E times F is not equal F times E. And this is the example we illustrate, at least a counter example. There are specific case que yes, pero too weird. The general is no equal. So basically, when you multiply E, que es 3, 5, 1, 2, multiplication 1, 2, 3, 4. Remember, the first thing you should do is checking the dimension. 2 by 2, 2 by 2. No problema, matching perfect the dimension. And we expect, when you end in the problem, you expect another matrix is 2 by 2. These two guys is these two, and these two is these two. Okay, let's do it. As you multiply, first row, first column is 3 EF. It's 3 times 1 is 3 plus 5 times 3, 15. It's 18, no? You see 18 where I come from? 3 times 1 is 3 plus, always plus. Well, no, so you have minus, it's minus, because it's plus minus, no? Okay, suppose that I want to find the second is multiplication, the first row and the second column is 6 and 20, no? 26. The next is second row, times this 1 times 1 is 1, is 6, is 7. And so now the last one is 2 and 8, no? Boom. Easy. Now I'm switching to verify that not always is the same. So now I multiply in different order. I multiply like that. 1, 2, 3, 4, and 3, 5, 1, 2. Okay, the dimension matching because we are talking about a square matrix. When the dimension is the same 2 by 2 or 3 by 3 or 4 by 4, it's a square matrix. It's a family of the square matrix. And then entonces es 3 plus 2 es 5. Es 5 plus is 9, is 1 times 5, 5, plus 2 times 2 is 4, and 5 plus 4 is 9, 3 times 3 is 9, 4 times 1 is 9, plus 4 is 13, and the last one is 3 times 5, 15, 15 plus 8, 23. And you see it's completely different, this answer to this answer. Okay, so in general, no. Doesn't match it. What the hell? Okay. Doesn't match the dimension. Okay, clear? So in general, the multiplication of the two matrices is not the same. Entonces, to a specification, the technical name is you pre-multiply or you post-multiply. For example, in this case, E pre-multiply F, because it's before. In this case, E post-multiply. This is post-multiply, and this is pre-multiply. And this is important. When you are doing the operation, you see the pre-multiply or post-multiply. Do you follow me? Do you understand the thing I try to explain? Or no?
Yes.
Okay. Let me see the attendance. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 students only. Kylie, definitely you can get inside. Kylie Garcia. What's going on? Okay, you cannot. Alejandro? Camila, are you there? Camila. Camila is always sleeping, no? Camila? Andrés, yeah. Yeah or yes? I am here. Okay. Gladys, as always, ready. Chelsea, Joshua, Jenny, Natalie, okay, Brianna, Walters, Edward Reyes, and Faisul Islam. Say something. Good.
Here.
Okay,
Here.
good. Okay. Faisul Islam, Brianna. Chelsea, I am here. Okay, okay. Okay, cool. Everyone pay attention. Do you understand the thing I am doing or no? Complicated? Okay, let me erase. Let me try to explain now inverse matrix. Now inverse matrix. I want to explain the last operation, and after we go directly to application. Inverse matrix. Okay, what is the definition of that? It's a matrix, and very similar. So suppose you have a matrix A matrix is 3, 5, 1, 2. Again, it's easy. It's 2 by 2, 2 row, 2 column. And this is the original. However, the inverse is denoted using that symbol. It's very similar to the inverse function, no? But in this case, it's inverse matrix. And I want to explain the formula. It's inverse. And thus now it's important to understand that it's only possible find the inverse matrix in the only for a square matrix and non-singular. This idea is not clear, but I want to explain in you a moment. So non-singular is confusing. I cannot explain now because we need another information, but the square is clear. The square is 2 by 2, 3 by 3. So you try to find the inverse matrix in the rectangular. It's impossible. Mismatch dimension, because this operation is only valid for the square matrix. Okay, so what is the most important property? The most important property is if you multiply the matrix A times its inverse, I want to explain the formula to find this. Unbelievable but true is equal to the multiplication in opposite directions. So you can commute the A and A inverse, and the answer stays the same. And by the way, the answer is identity matrix. So in a few seconds, I want to find the inverse. And let's do in the multiplication this and this in either order, and you get the identity matrix dimension 2. Okay, identity matrix dimension 2 is 1, 1, 0, 0. So remember, when you're talking about identity matrix, it's a matrix, it's a square, number 1, And number 2, the main diagonal is just 1 and the rest is 0. Suppose identity matrix dimension 3 is 1, 1, 1, and the rest is 0. Actually, we have 9 entry because it's 3 by 3, no? 3 times 3 is 9. So 2 by 2 is 4. Clear? So what is the formula to find inverse? Well, in 2 by 2 is super easy. And 3 by 3 and 4 by 4 is extremely complicated. That is the reason that I never doing by hand the inverse matrix in 3 by 3 and 4 by 4. But in 2 by 2 you can do by hand or either way or software, no? The idea is suppose you compute one thing. Okay, I want to explain in a few minutes, but I want to anticipate a little bit. Is the determinant. Determinant is represent like a 1 bar like that. This is determinant. Determinant. And the determinant is similar to the matrix, but it's completely different concept. And the student confused regularly. You using bar similar to the bar that we use into the absolute value, but actually no absolute value is another thing. And you apply the formula for the computation, the determinant 2 by 2 gets easy as multiplication this and this, and you assume the same sign positive, no positives, the same sign. So this positive is the mnemonic device to remember get the same sign. And you multiply this and this, and you put negative, indicate also que es opposite side. Okay, so now basically in this example, 3 times 2 is 6, it's positive, stay positive, and 1 times 5 is 5, but it's negative 5. So the answer is 1. Nice. Now the determinant is 1, because it's a part of the formula. It's a part of the formula. So what should I do? Well, in this case, I find easy example. I try to don't complicate your life. And the review package you see more clear. Now, in order to find the inverse function, the action that you should do is, let me explain in detail. You take the original, okay, 3, 5, you interchange these guys. You put 2 here and 3 here. Boom. And the other diagonal stay the same, but the opposite side is negative 5 and negative 1. Boom. And multiplication by a scalar number gets 1 over absolute determinant A. But in this example, it's 1. That's not necessary. This is invisible. Nice. And this is the inverse. Let's verification, see we are doing well or not. Do you understand the idea? Okay, repetition. You compute one thing, get the determinant. It's a number. In this case, 1. I create easy. To don't complicate. Si es 2, entonces yo divide by 2. Pero si es 1, no. Divided by 1 stays the same. Now, the organization inside the matrix, inverse matrix is you interchange the main diagonal. So you put 2 in the place of 3, 3 in the place of 2. No, with the same sign, no change the sign. And the other diagonal, que es secondary diagonal, 5 and 1, you stay the same number but opposite side. Done. Divided by 1, okay, 1 is nothing. Therefore, I guarantee you 100% that A times A inverse should be equal identity matrix. Let's do it to verify that. 3, 5, 1, 2, que say the original time 2, negative 5, negative 1, 3. Let's do in the multiplication. First of all, I want to check the dimension. Oh, it's 2 by 2, 2 by 2. So we expect 2 by 2 matrix. 2 by 2. And when you multiply 3 times 2 is 6. And 5 times negative 1 is negative 5. So 6 minus 5 is 1. Let's do in the second operation. This 3 times negative 5 minus 15. 5 times 3 is positive 15 is 0. 1 times 2 is positive 2. 2 times negative 1 is negative 2. 2 positive and negative 2 together as 0. And the last one is the row 2 and column 1 get negative 5 and positive 6 as 1. Bam! And you see clear like water. Okay, this is the identity matrix, and you understand now what is important, this conclusion. And likewise, to practice a little bit, you are doing in opposite direction. You suppose that you multiply this and this. I guarantee you that we get exactly identity matrix. Now let's do it in this order. 2 negative 5, negative 1 3, times 3 5, 1 2. Okay, let's do it. Is 6 and negative 5 1, 10 and negative 10 is 0, negative 3 positive 3 is 0, and negative 5 and 6 is 1. It's again identity matrix. Cool? This is the formula. This formula is only valid for 2 by 2. Si es 3 by 3, no. Entonces, pero I want to explain in the software, 3 by 3. So nobody is doing by hand 3 by 3, 4 by 4. This is crazy. Okay, and 2 by 2 is possible, doable. But you can use the software always. Yes, you can use the software always. And what is the formula? The formula for inverse 2 by 2 is, let me copy here. The guy is plain, but why not? It's easy to remember the formula. Suppose you have A, B, C, D. So you compute one thing is called determinant. It's A, B, C, D. It's multiplication, this and this is AD positive. And this and this case minus CD. Right? And you divided everything. Now the action is you interchange. You put D here and A here. And B and C stay the same but on the opposite side. And you divide by this. 1 over AD minus CD. And this is the formula, guys. But don't worry too much, because I want to explain in detail now in the software. This is the advantage. You understand that the solutions of the linear system of equation is easy. But what is the problem? It's too long. And when it's too long in mathematics, when something is too long, everyone makes a mistake. So to organize this work, the mathematician discovered this way. It's a matrix. And the matrix organize elegant the idea, and also now the computer science engineer creates software, no? Solving, pero using matrix. Okay, let me explain completely the idea behind this. Any question? Do you follow me? Look like horrible, complicated. I follow. Okay, cool. Jenny is following. Only Jenny, the rest is okay? Okay, entonces I suppose que you see my whiteboard. Entonces now, what is the application of this? Well, in the last class, we studied in detail one fantastic way for solving linear system of equation, que is using the reduced row echelon, no? Ese command form. This is the first one. I like so much this, but we study now the second way, is using inverse matrix. What is the idea behind this? Suppose we have a system. Let's start at the beginning from scratch. 3x minus 2y plus c equal to, this is my first equation, x plus 4y minus 2c equal 6. I need to check in detail, because you change one number or change one sign, you are solving another completely different problem. 2x plus 5y minus 2c. Oh, I make a mistake. Look, this is minus c, not 2. I copy this, the equation, the third equation, equals 6. It's 6 again, coincidence. 3. This is the system. In the last class, we learned how we solve that. We learned using the augmented matrix. And the augmented matrix is a combination. It's a combination, so we're using the same coefficient 3, minus 2, 1, line 2, 6, 1, 4, negative 1, 2, 5, negative 2, and 6, and you put inside the software and you apply this function. However, I want to explain now that function. That function is different organization. I suppose we have one matrix square is only formed by coefficients in front of the variable. Let me call this matrix capital A. Okay, 3 by 3 is a square. And maybe it's invertible. Now I have another column vector, que es B, que is formed by the right hand side, que es 2, 6, 6. Okay, and I create artificially another column vector, que is capital X, this capital, que is formed by the variable is X, Y, Z. So this X, Y, Z is the original variable we have in the problem. So I call the combination every variable like in one capital X. So we know the concept, the new concept of the multiplication of the matrix, and you can write this system in matrix form. How? Matrix A times capital X equal B. Let me verify see this is correct or not. Okay, see it's correct, see I'm doing well, see this is logical or no. Suppose 3, 1, 2, negative 2, 4, 5, 1, negative 1, negative 2, multiplication by the variable is X, Y, Z is equal 2, 6, 6. Okay, now I perform this multiplication. This is period time multiplication, and the multiplication is minus 3x, sorry, 3 times x minus 2y. So you multiply this times this. You put in the first. Plus 1c. Okay. This is 3 by 3, and this is 3 by 1, and we expect 3 by 1. Okay. But the problem is that the entire row 1 is 3x minus 2y plus c equal to, because we have equal sign. This is my first equation, and my second is the same. It's x plus 4y minus c equals 6 again, and the last equation is 2x plus 5y minus 2 minus 2c equals 6. So now I confirmation good. Okay, this matrix form is equivalent to the system at the beginning, right? Now how you solving using this new idea? Well. Okay, how you solving, for example, in algebra, kindergarten algebra, elementary algebra, this equation, 2x equals 4. Well, you divide by 2, both sides, and you get x equal to, right? This is classical. We are doing exactly the same idea, but in multi-dimension. You take this equation, let me try again to copy, bring down. I organize in this way. Here I want to do several operations inside this, and we discover a formula. Suppose que you pre-multiply, pre-multiply, because I need to be careful with the multiplication because it's not the same post-multiplication and pre-multiplication. You multiplication both sides by the inverse matrix of A, so A inverse multiplication A, multiplication X is equal A inverse multiplication B. This is perfect licit. It's valid, right? Pre-multiply both sides by the inverse matrix. But I know very, very well that this multiplication is equal to the identity of the same dimension, see 3 by 3 or see 4 by 4 or whatever. And this in the right hand side we have inverse matrix time B. And you know also that identity matrix multiplied by any vector or any matrix is exactly the same this vector or matrix, because identity matrix working like a one dimension M, because it's like that. Suppose que es dimension 3, because my problem is 3, is 1 1 1 0 0 0 0 0 0. When you multiply this matrix is identity matrix dimension 3 or dimension M, suppose que es 25 equation, doesn't matter. Multiplied by any vector or any matrix is like a 1, invisible multi-dimension 1. Entonces the formula is this. The only thing you should do is you take the original matrix A and the original matrix B. Okay, you take directly in the system, no? And you apply the inverse function of A, and after multiplication by B, boom, and you get the final answer. Okay, let's do it. Of course, let's do it not by hand. Let's do it in the software. Of course. So in the software, do you follow me? You understand the idea? It's another technique. Use a matrix for solving the linear system equation. Okay. I promise we have one more technique, 3 techniques. But in the test I am specific. I want you solving by inverse. I want you solving by echelon. You solve it by echelon. So you solve it by another method, no credit. Or we have another way. I want to explain now. Let's come back to the GeoGebra. Let me share the screen. Do you see GeoGebra? Yes or no? Answer me.
I can only see.
No? Try again. You see my face now?
Yes. Yes.
Okay. Now?
I can see it.
No, can't.
Can. Sorry. Yes.
Okay. Okay, so now I want to start new problem. So I delete everything. Let me see. Delete. Let me see. I select the information, delete. New problem, new spreadsheet, new. Okay. This is the beauty, guy. And the editor, you can, if you want, recording the problem one by one, you can, of course, you save, and that's it. Oh, no, you start new problem, you erase everything. And this problem, the matrix A was, you let me know, say make a mistake. 3 minus 2, 1. Remember, I taking only the matrix A, que is the matrix of the coefficients in front of the variable. I omit, for a moment, right hand side. It's not like augment. Augment is both together. No, this is another procedure, algorithm. This is a 1, it's a 4, this is -1, and this is 2. and -2. Cool. This is my matrix A. I select everything, drag when the hold the left click mouse. Now press right click and create the matrix. And this matrix I want to rename. Let me verify first see it's okay or not. 3, -2, 1, 1, 4, -1, 2, 5, and -2. I'm checking guys because it's frequently me and everyone making mistake. It's a matrix A, capital A. According to the formula, well, let me type in now B. B is the right hand side number, okay, 266. This is B. I select, I create the matrix, I rename B. Okay, now let me try to do it step by step. In the cast, you find the inverse matrix. And inverse matrix, I normally forgot the name of this because it's very weird. But okay, it's inverse. You put inverse, you don't know anything, you put in capital, no, inverse, invert. I suppose it's invert. Yeah, it's not inverse, it's invert. And you click here, invert what? Invert matrix. Boom. What matrix? The matrix A. You press enter. Bam! And you get the fractions. This is the inverse matrix. Where come from this fraction? I suppose when you compute the determinant, you get the fractions. But I don't care. It's not important. Now, in the cast window, you continue the operation because in algebra, you deposit the matrix. So the transfer is a spreadsheet help me to edit easy. Transfer to algebra. And this is the operation. The operation is this. And now you multiply the inverse A. If you want to copy, let me see, copy. Yeah. Control C, Control B, copy paste. Multiplication is the same operation as after is the Shift A and matrix B. When you press enter, bam! This is the answer. The answer is 1, 2, 3. I create for you in this order 1, 2, 3. And what is the interpretation? The interpretation is the first component is X is 1, the Y is 2, and Z is 3. End of story. Do you see that?
Yes. Yes.
Cool. I promise in the review package, we are doing at least 2 problems of this. For a moment, it's enough. Let me try now to explain determinant. It's the last topic, determinant. I come back to the whiteboard again. Switching whiteboard. Okay, there you go. Do you see whiteboard or no?
Yes.
Cool. Now determinant. It's the last technique, the last algorithm. Determinant. Determinant is different. Determinant is the notation. So the determinant is applied only in the square matrix. And what is the idea? The idea is you take a square matrix and you associate like a function. You associate one number, one real number. So when the one a little bit complicated algorithm, sometimes no, sometimes yes, you associate, this is a function, associate square matrix as one real number. And what is the connection? What is the algorithm? Well, in 2 by 2 is pretty easy. 2 by 2 is pretty easy. Look, suppose we have 2, 3, 4, 5. And you multiply. This is multiply like that, is 10 positive. And multiply like that is minus 12. And the answer is negative 2. Okay? Super. Now, I try to find. No, it's okay. It's okay. 3 by 3 is very, very complicated. It's very, very complicated by hand. And let's do it using the software. Okay? Using the software. So what is the application of this? The fantastic application of this is the famous Kramer rule. Kramer rule. And Kramer rule helped me for solving system of equation using determinant. What is the idea? What is the idea? I want to explain one example. Of course, this example we're solving in detail in the software because it's 3 by 3. Suppose this example. You have a system like that. X minus y plus 4c equal 4. This is my first equation. My second equation is 2x plus c, so y is missing, equals 0. Wow, equation 2. And the third equation is minus x plus y minus 4c equal negative 8. Now we're using the same notation, no? This is you enclose to understand that this is the system, no? Is you need to solve the system means okay, you try to find the point, okay, both the 3 equations satisfy, no? It's the connection is and between the equation, no? It's the intersection. But what is the Kramer rule? Kramer rule compute determinants. Determinant, I call capital D. Capital D is the determinant of the coefficients in front of the variable. Okay, 1, negative 1, 4, 2, 0, and 1, and negative 1, 1, and negative 4. And this give me one number. I have no idea. In the software you can see. Now, Kramer rule say, after you compute one thing, it's called dx. Oh, and dy and dc. Another determinant of each variable, x, y, and z. And the only thing you need to organize is you copy now the right-hand side number and the column that corresponds with the same variable. For example, 4, 0, and negative 8. 4, 0, and negative 8. You put in the first column because the first column is the x column. And the other stays the same. You replace the right-hand side column and the column corresponding with the name of the determinant. Likewise, and dy would be 1, 2, negative 1 stay the same, like the original 4, 0, minus a, and the y column and the z column, no, stay the same. And the z is 1, 2, negative 1, negative 1, 0, positive 1, but you replace the c column is 4, 0, and minus 8. This is the c column. Do you follow me? Do everyone understand very well this or no? Okay. And to compute that, of course, it's too hard, too complicated by hand. No, nobody doing it by hand. Now we are doing using GeoGebra, no, of course. I want to explain in detail the fantastic way to make easy this idea. Okay, I open my GeoGebra. One more time. I try to switching GeoGebra classic. Guys, you have to practice. And you see GeoGebra or not yet? Not yet? No? Yes? I see. Okay, cool. I don't realize. Okay, I'm doing well. Okay, now you erase everything in the last problem. And you be careful now. Typing, you know, I want to type in here the D, que es the coefficient in front of the verb, que es 1, -1, -1, 4. Si I make a mistake, you let me know. 2, 0, and 1. This is the classical example, guys. The mathematics, they are complicated, theoretical, but this is not complicated, but it's too long. And the thing is too long, everyone makes a mistake. Because in one moment you are tired, and you don't see very well the number, right? Now you copy the coefficients. Separately, I copy why not the coefficient in the right hand side, que 4, 0, and negative. Do you follow me? The thing I'm doing now?
Yes.
Cool. Now I take advantage like Excel. You select this and copy. And paste here. Here. And here. Because I want to build dx, dy, dz. So now the only thing you should do is copy this. And copy and paste here in the first. Oh, I did well. In the second. Paste in the third. Do you see the thing I'm doing?
Yes.
Okay, now one by one. So relax, slow down. You select this and compute the determinant. You create matrix, of course. Bam. And this matrix, maybe I change the name. You put the name is capital D, no? Actually, capital D is no matrix. Capital D is determinant, and determinant is associated with the number. And you go to CAS. In CAS, you put determinant. Determinant. Oh, there you go. Determinant of the matrix. And the matrix I call D. And the answer is 0. Oh, coño. I select not good example because when the D is 0, we cannot apply. Hello. Carajo. Okay, in the review package, I have another example. Now, immediately you see that D is 0, you cannot apply the Kramer rule because I forgot to say something. Look, I forgot. I come back again to the whiteboard. The answer is 0. Wow. I have another example. But okay, forget about this. Let me finish the theoretical part, and after in the review packet we dedicate one piece of this lecture to the review packet on Wednesday to finish the review package. Okay, let me try to share again one more time the. I need to verify this, but okay, no problem. We have time. Do you see whiteboard? This is 0. Yes. This is 0, and this I don't know. But we can compute. Suppose que no 0. Suppose que it's another number. So now to find x, y, and z, the only thing you should do is divide dx divided by d. This is just a number. And y is dy divided by d. Always in the denominator is d. Suppose que es 0, entonces no, it's undefined. And c is dz over d. This is the Kramer. Okay. Okay, sorry guys, because this example, but in the package we have a fantastic problem. Okay, so now let's move on to the package. I don't remember if I sent before or not the package. Do you I sent before or no? No. Today is the first day I sent the review package, no? See, I sent today. Okay. Okay, let me start for the question 1, get super easy, straightforward, elementary, kindergarten problem. Is shut the 4. Is this? I guess so. Yeah. Page 1. Look. Do you see very well the whiteboard?
Yes.
Entonces, the question 1 is super elementary. It's verify. And to verify, you don't need to solve it. No. One solution is given and you plug it in into the equation, one by one. See, everything is true in the equation 1, equation 2, and equation 3 is solution. See, at least one equation failed, no solution. Okay? And you solving equation by equation. You suppose the solution is given and the problem is x equal 3, y equal 2, and c equal -1. And you take equation by equation. Equation 1. Equation 1 is x, que es 3, plus y, que es 2, plus c, que es -1, entonces minus, should be 4. Y I claim this. It's obviously true, right? 4 equal 4 is 2. Let's move on to equation 2. Equation 2 is x, que es 3 again, minus y, que es 2, plus 5c, 5 times -1 should be equal 12. It's 3 minus 2 minus 5 should be 12. This is obvious que no, because 3 minus 2 is 1, and 1 minus 5 is -4, and minus 4 is not 12. It's completely false. Now the answer is no solution. So this solution is given in the problem, I verify que no, doesn't work. Do you understand? Well, another possibility is, well, no, so you lie, you solve the system and compare the solution that you get with the is given. But no, it's easy verification. Everyone follow me? Cool. Okay. Yes. Okay, question 2 is also easy because it's given one system of equation, but this system is expressed like an echelon. How do you know it's echelon? Because in negative 2, equation 3. Because in the first equation we have x, y, z, but in the second equation x is missing. And the other equation is missing x and y. This is a typical echelon. And when you have echelon, we can apply back substitution. It's the easy way. And back substitution is it's obvious que c es -2, no? Taking this equation. Now plugging in c in the second equation, we have 5y plus 3 times -2 should be 4. This is 5y minus 6, 3 times -2 is minus 6 equal 4. 5y is equal to 4 plus 6 is 10. Divided by 5 both sides. Es obvio que y es 2. C es -2. and x, back substitution, I go to the first equation. In the first equation, we have x plus 4 times 2, because y is 2, plus 2 times negative 2 should be 3. Entonces we have is x plus 8, no? 4 times 2 is 8, minus 4 equal 3. 8 minus 4 is 4 positive. And x is equal 3 minus 4 is negative 1. And we obtain the solution point, a unique solution. Is the point you express it like a triple order, negative 1, 2, negative 2. Okay, the option A. Let me see, the option A. Negative 1, positive 2, and negative 2. Everyone following?
Yes.
Okay. Nice. You know, always happen in the review, the students see clear the idea, no? Because it's you see the movie and this repetition of the movie, so you see the detail more clear. Okay, number 3 now. Number 3 is a system x plus y plus c equal 10, equation 1, and x minus y plus 3c equal 14, equation 2, and 2x plus 2y plus 2c equal 12, equation 3. Okay, we can do it in different way. Of course, in the classical idea, we stood at the beginning. Okay, you take 2 equations and eliminate y, for example, and you can do that, but we take advantage the matrix, no? Or no. Look, you see, in specific this problem, I see one detail. The last equation, number 3, any coefficient is 2, 2, 2, and 12. It's divisible by 2. So you can divide it by 2, divided by 2, divided by 2, and divided by 2, the equation 3. And you know, okay, when you divide or multiply by a number, the equation is the same. It's dependent, it's the same. We have x plus y plus c equals 6. And this is the new equation 3 after the division by 2. And I see something weird, because this equation and this equation is a contradiction, because x plus y plus c is 10, and also x plus y plus c is 6. This is a contradiction. Or it's 10 or it's 6, but not both. This is typical no solution problem. And the technical name to call no solution is inconsistent, because we have no solution. Inconsistent. When a system is consistent, we have solution. Perfect. Wait a second. Show you. There you go. Okay. Everyone follow me? Clear or no? Okay, let's move on now to the partial fraction decomposition. Entonces, the question will fly in the air. Professor, you can do it another way. Suppose I don't see this idea. Yeah, of course. Of course, you can do it another way. What is the another way? You put in the matrix, like that. 1, 1, 1, 10. 1, negative 1, 3, 14. You put 2, 2, 2, 12. And you put in the algebra. This is the 3x4 matrix, matrix. And you see that we have contradiction. No? Do you want to do or no? Yes or no? Yes. Okay, Jenny said yes. Okay, Jenny. Let's do it. Okay. Okay, let me copy the matrix in the piece of paper. 1, 1, 1, 10. 1, negative 1, 3, 14. And 2, 2, 2, 12. Carajo, mira que la gente jode. Okay. I'll bring off. Okay. Look, Jenny. I open GeoGebra. I want to erase everything. There you go. Let me share the screen, Jenny. There you go. Do you see GeoGebra, Jenny?
Yes, yes, I see.
Now you type in 1, 1, 1, 10. 1, negative 3. No, negative 1, sorry. Negative 1, 3, 14. Enter. 2, 2. 2, 2. Another 2. And 12. There you go. I select. I convert to matrix. This is right. Boom. I'm watching just in case I make a mistake or no. It's supposed to no. Okay, I don't rename, not necessarily rename. Now I apply the method, the first method that we studied is reduce the row, reduce it. Reduce it, you type in reduce automatically, reduce the matrix M1. And you press enter, wow, and you get this answer. And this answer, I can see no solution because in the last equation, in the last row, we have 0, 0, 0, and 1. That means 0x plus 0y plus 0z is equal to 1. This is a contradiction. Cool, Jenny?
Yes, yes.
Cool. Let me come back to the whiteboard now. Either way, guys. Either way. Using common sense, you're using imagination, you're using software. One way you justification. Okay, no solution. It's inconsistent system. Let me, you see whiteboard or not yet?
Yes, yes.
Okay. Okay, let's do it now. Oi, partial fraction decomposition. I propose doing not all of them. We have a lot of examples of the partial fraction decomposition in this package. I want to do, let me see how many. I want to do 3. And we have 2 more. 2 more complicated. Because the complicated, I left for you. I left for you, y I consider like an extra credit. Entonces now when you send me back the answer, I consider the question number, let me see, 4, no, 4, 8 I want to do, 5 I want to do, 6 I want to do, but 7 and 8 no, it's extra credit, right? It's complicated for the smart student, for the advanced student if you want to, or any student that need to improve your grade, take advantage. It's a new extra credit. Okay, now we have x minus 6 divided by x minus 2 times x minus 4. Oh, nice. Why it's nice? Because this is the factorization of the bottom part of this rational expression. It's given, y I appreciate so much this favor. Okay, entonces I know que the factorization is 2 factorial, non-repeated, and we have x minus 2 and x minus 4. I want to call arbitrary letter, AB. It's obvious that the least common denominator is x minus 2, x minus 4. And when you multiply this entire expression by the LCD, stay alive, x minus 6 equal a times x minus 4 plus b times x minus 2. Everyone follow me?
Yes. Yes.
Okay, so I take advantage of the smart value. The smart value maybe is x equal 4. Because I know when you plug in 4 here, 4 minus 4 is 0, disappear the a part, and the b stay alive. Entonces 4 minus 6 is equal, this is gone, it's b times 4 minus 2. 4 minus 6 is negative 2. 4 minus 2 is positive 2. Therefore, b is negative 1. Boom. Now, another smart value is 2. Because when you plug it in, the part that disappears this, because 2 minus 2 is 0. So when you plug it in, the original is 2 minus 6 is equal to 8 times 2 minus 4. And that part is 0. This is negative 4. This is negative 2a. Divided by negative 2 both sides. A is positive 2. Now the solution is the final answer. It's similar to the option C. Look, A is 2 positive and B is negative 1. Any question? Any question? No problema. Do you see super clear or super complicated? All right, show me. Clear, Johnny. And the rest students? No question. Remember, this is a review. What's the idea to doing this? The idea is because reinforcing any concept one more time and clarify everything you need. So take advantage and ask me any question, Edward. Okay, number 5. Number 5 is 4x squared minus x minus 13 divided by x minus 2 and x minus 4. Oh, again, it's similar. Is the factorization of the polynomial in the bottom is already done. But I know I make a mistake. Hello, I'm crazy. I'm crazy. I copy the top part of the equation 4 and the bottom part of the equation. It's x plus 1 and x minus 1. Oh, cool. We have 3 factors. 3 factors not repeated. Que es x plus 1 maybe. The order is not important. And x minus 1. So you put in different order like me. Okay, and you call different letter like me. You call, for example, I call A here, B here, and C here, and you call in different order A, B, C. Of course, the answer is the same, but A is no A. It's another A, no? It's B, because you interchange. Okay, now the least common denominator is x times x plus 1, x minus 1. When you multiply everything by the LCD, stay alive, 4x squared minus x minus 13 is equal to 8 times x plus 1, x minus 1. Because the only thing it cancels is x, this x, and this x, plus b, x times x minus 1, plus c, x times x plus 1. Everyone follow me? Do you understand very well this or no?
Yes. Yes.
Mm-hmm. This is easy because you can take a smart value. For example, you take x0. What is the intention? The intention is that this is cancel out, gone, and stay alive only a. And 0 is minus 13 is equal a, 0 plus 1, and 0 minus 1. 0 plus 1 is 1, 0 minus 1 is negative 1. Entonces, negative 13 is equal minus a, no? Therefore, a alone divided by negative 1, both sides is 13. Positive. Is 13, yeah. Okay. Now, of course, I take advantage. I have a in my hand. You evaluate now at x equal 1 positive. When you evaluate at 1 positive, it's obvious because this is 4 minus 1 minus 13. Que es negative 10, no? Es 4 minus 1 is positive 3. Positive 3 minus 13 is negative 10. Is equal to this guy que disappear is this. And 1 here disappear also, no? And stay alive, C, no? Entonces es C times 1 and 1 plus 1. Because x is 1, no? Y 1 plus 1 is 2, 2 times 1 is 2. Entonces es minus 10 is equal to C. Therefore C is negative 5. Boom. Likewise, so you are doing another smart value. This is nice. This is the problem I want to put on the test, of course. Negative 1. And then it's a little bit different because it's 4, 1 squared, 1 positive. There's a double minus plus 1 because the negative of the expression and negative 1 together is positive. Minus 13. Minus 13 equal B. Because A is gone, C is gone because negative 1 plus 1 is 0, and they stay alive negative 1 and negative 1 minus 1, que es negative 2. And negative 2 is positive 2, no? Entonces we have here, this is 5, this is negative 8, no? Equal to B, no? Because negative 1 and negative 1 is negative 2, and negative 2 multiplied by negative 1 is positive 2, no? Divided by 2, both sides is negative 4. Okay, the partial fraction decomposition in this case is the option. Let me try. The option B, I guess so. Look, because A is 13 positive and B and C are negative, both negative 4 and negative 5. So who is C? Who is C is the associate with the x minus 1 is 5, no? Okay, and negative 5 here. B is negative 4. Okay, and this is my final answer. I know it's too long, sorry, but it's no big deal. Any question? What part is confused? What part do you want me to repeat again for you? No? Let's move on to the page 2 now. Cool. Page 2. This is the page 2. Okay. Let's do it number 6. Remember, 7 and 8 extra credit. 5 points, extra 5 points. So you're doing well, everything, you have 110. Plus 5 points that you do is 115. Okay, I know it's too long, sorry, but it's doable. Suppose now number 6, basic we are doing now here. Number 6 is 80 minus 14 x divided by x cubic minus 8x squared plus 16x. Wow, the problem is, well, the problem is, and the other problem was easy because somebody do the factorization of this, but on this, no. I need factorization the polynomial and the denominator. The great common factor is obvious x. We have x squared minus ax plus 16. Now be ready to factorization the trinomial. X to parentheses. X, and the combination can open the door of the trinomial 4 and 4, because 4 times 4 is 16 and 4 plus 4 is 8, and both negative. Wow. So now we discover in this rational expression we have 80 minus 14x, and we have x and x minus 4 is squared, because they are twin brothers, because this trinomial is perfect square. Therefore, the partial fraction decomposition, when you include repetition, real, is different. Because we have 3. We have x, and we have x minus 4 one time, and x minus 4 two times. It's the typical format of the partial fraction decomposition when you have multiplicity different to 1. I call ABC. Everyone understand this format? Si es 3, es 1, 2, 3. It's too long. Yeah, Rachel. Okay, entonces, what is the least common denominator? Bueno, the least common denominator es obvio que es the multiplication. Bueno, no, it's not obvious. It's x times x minus 4 squared, right? It's the least common denominator because the rule for finding LCD is you take every factor involved in our problem, but when you have repetition, you take majority and not necessarily. This is totally irrelevant. This is irrelevant. And the LCD effect that you take the higher exponent and you multiply everything by this. It's obvious it's cancel out everything. Just we have 80 minus 14x equal 8 times x minus 4 squared plus bx x minus 4 no square plus cx. Do you understand this or no? Cool. Do you understand the sophisticated detail, the LCD? Que es x minus 4, no x minus 4 times x minus 4 squared. No, in the original, when there's non-repeated, you take everything. But when there's repeated, no. You take, see, there are coincidence of the factor, because x minus 4, you take the majority exponent, right? Now let's just start with the smart body. Suppose the first is 0. Because 0 guarantee that this is gone, and this is gone, and stay alive only 80. The 0 here is 80, is equal 8, and 0 minus 4 squared. 80 is equal 16a, no, because negative 4 squared positive 16, no? And divided by divided by 16 and 5, no? Both sides. A 5. Cool, I have the first one. The second is smart value, maybe is 4. And what is 4? This is gone. This is gone, and stay alive C. So it's 80 minus 14 times 4 is equal to C times 4. And 14 times 4 is 56. So 80 minus 56 is 24 equal 4c. Therefore, c alone divided by 4 both sides is 6. Unfortunately, we have no more smart value. This is a smart, and this is another smart. And to be smart, because it's create a one factor is gone. But I have in my hand, I take advantage. I have in my hand A and C. The only thing I compute B, and that's it. So I take, for example, one no smart per frame value, que es 1, or negative 1, or 2, or 3. I suppose that 1 is easy. Entonces 80 minus 14 is equal, entonces now I copy A5. And we have 1 minus 4 squared, because x I suppose is 1, plus b, I don't know, I have no idea, b, times 1, times 1 minus 4, parentheses, this is 4, sorry. Let me make a zoom. This is minus 4. No square, okay. Plus, plus c. Times 1, but c is 6. Okay, the only unknown is b. So this is 66 is equal 1 minus 4 is negative 3. Negative 3 squared is 9. And 9 times 5, 45. Plus no minus. Because 1 minus 4 is negative 3. Times 1 is negative 3b. Negative 3b. Plus 6. Cool. What should I do? Well, you combine. 45 and 6 together is 51, no? Minus 3b. Therefore, b alone is 66 minus 51 divided by negative 3. The answer is negative 5. This is b value. Sorry. Entonces, the answer is, let me see, in our paper, is 5, negative 5, and 6. Is the option, let me try to see. Oh, yeah, it's this. 5, o sea, A es 5, B es negative 5, and C is positive 6. Es the option C. Clear? Any question? No? What happened, guys? Are you mute? Any feedback? No, to motivation, clear, okay. It's Jenny only the student get, okay, glad. Okay. Okay, let's move on to say, remember 7 and 8 is extra credit. Guys, this is important in calculus 2. The teacher, okay, I will explain calculus 2, suppose. Okay, you need to know very well partial fraction decomposition, because we use in calculus 2 like a one method. So this is part of the another more important and complicated thing. Okay, number 9 is non-linear system of equation. We have two equations and two variables, two dimensions. X squared plus y squared equal 25. Equation 1, of course, non-linear. an equation x plus y equal -7, que is linear. And remember the classical solution of this, you take the linear, isolate the one variable, x or y, whatever you want. In my paper, I isolate, you take the linear equation. In my paper, I isolate y, but you can isolate x, is -7 minus x. And you taking this expression and plugging in where? Here, in the y place, in the another equation. Not in the same. In the same, you get the cyclical, you never get the answer. Okay, so now my equation so far is x squared. I copy x squared, get this x squared, look. Plus, no y anymore, no, it's -7 minus x squared equal 25. Okay, we focus in the solution of this equation. Okay, remember the quick foil. You see the negative here become positive, yes or no? Do you understand why, no? Because it's a square, and everything is a square become positive. Okay? And the quick foil is x squared plus the square root first get 49. What comes from 49? It's 7 times 7, no? Plus 2 times multiplication twice, 14x plus a square the second equal 25. Any questions so far? Do you understand the quick foil? Yes or no?
Yes.
Okay, now combine like term. This look like quadratic equation, no? Look like quadratic equation. You combine, you put 2x squared plus 14x. And why no? I move 25 to the left. And to say 49 minus 25, 24, no? 2x squared plus 14x plus 24 equals 0. And you can see, wow, you can divide by 2 this equation in order to make easy. Divided by 2, because it's even, everything is even, no? So this is x squared plus 7x plus 12. Wow, fantastic, equal to 0. And we solve the same in 1 second by factorization. Okay, is 4 and 3. 4 times 3 is 12, and 4 plus 3 is 7. Positive everything. Now x plus 4 equals 0, corresponding with the solution -4. And x plus 3 equals 0, corresponding with the solution -3. Okay, now we almost finished. I go to the original equation. Okay, but you take advantage. Let me see what's the best way. You take this equation. So you take the solution of -4, and you plug it in into this to get the y value. Y is equal -7 minus. Be careful with the sign, guys, because x is -4. We have double negative become positive. -7 plus 4 get -3. So in this moment, I don't wait for more time. I write the order pair associated with the solution, okay? -4, -3. And likewise, I taking -3. And again, plugging in the same equation, in the linear equation, -7 minus -3. Okay, it's -7 plus 3, okay, -4. Therefore, the point is the point -3, get the x component, comma, -4. Cool? Let me check it. Checking. We are doing number 9. And number 9, in my opinion, is this one. B option. Remember, the test we have no multiple choice. In the test you need to show me the word en detail. Y I'm detecting the student que write nonsense thing. You need to do in the systematic way like me. Some people que copy for another student, no? Don't understand anything. I copy nonsense. I immediately detecting que es nonsense. Nonsense is 0. Any question? Let's do one more. I will continue Wednesday, the review package. Number 10. I can erase?
Yes, yes.
Okay. Okay. Oh, it's easy. Well, it's similar. You have one equation que I take advantage. Que y is isolated already. Equation 1, so I don't need to do this job. X squared plus y squared equal 25. Equation 2. Okay, that's what the idea. The idea is you take this expression. Okay, it's already isolated, plug it in here. And another equation. Entonces, x squared plus paréntesis minus x squared plus 13. X squared equal 25. Entonces, doing substitution, you eliminate one variable, y is gone. Solving this. Now, quick foil. Quick foil. One more time. But be careful with the quick foil because we have minus inside. Entonces, you put a square first. Okay, no problem. Okay, it's x squared positive, of course. No, it's square. It's 4 power because it's square. X squared negative x squared. Is x to the 4 power positive, no? But this is minus because we have at least one minus. So you have two negative, entonces you factor out like a -1 and -1 squared positive 1. But you have one positive and one negative. Your interpretation is negative. Multiplication both is 26 times extra 2, 26 x squared. I make a mistake here. This is 4, no? Minus 26 x squared plus square the last is 169 minus 25 equals 0. Because look like, I suppose, quadratic equation, or at least quadratic in front. Entonces, x to the 4 power minus 25, que es the subtraction, 1 positive and 26 negative, plus 144 equal to 0. Okay, this is a little bit more hard, but we can do if you want. So you can using the use substitution because it's quadratic in front, no? Quadratic in front, or not necessarily. You factorization. Look directly. Square root of this guy is x squared, no x, and the combination that open the door is 16 and 9. Because 16 times 9 144 and 16 plus 9 is 25 and both negative. Wow, so immediately you obtain, this is one possibility, guys, or two different of a square and you factorization again like that, x and the square root 16 is 4 and the square root 9 is 3 plus minus. And we have 4 solutions. One solution is this, que corresponde a -4. Another solution is this, que corresponde a +4. Another solution is here, que corresponde a -3. Another solution is here, que corresponde with the +3. It's one possibility. Another possibility is, in that moment, you separate like a quadratic equation, and you solve it using the square root method. Apply square root both sides, and the square root 16 is 4, and you put plus or minus, and you get exactly the same answer. And that's it. No. I need to find now the y value, no? I have to find the y value, I substitution, and the Easter equation, because of course the linear is waiting for me because y is already isolated. So y alone, but in this case I take advantage, get the same number, positive and negative inside the square. This is minus, I plug it in both, positive and minus 4 squared plus 13. So this is 16. Actually, minus 16 plus 13 is negative 3. Oh. At this moment, to don't lose the path, I taking 2 points, negative 4, negative 3, and positive 4, negative 3. Because both positive 4 and negative 4 get the same y value. Likewise, now we're using this. Is negative plus or minus 3 squared plus 13. Entonces es negative 9, no? Because 3 squared is 9. Doesn't matter if it's positive or negative. It's negative 9 because this state is negative. Plus 13 is positive 4. And the point are minus 3, positive 4 and positive 3, positive 4. Okay, let me try to find the solution in this paper. The option, let me see. I suppose it's B. In B we have 4 solutions. 4, negative 3. Let me checking. Yeah. 4, negative 3, negative 4, 3, negative. Let me see, positive 3, 4. And negative 3, 4. Cool. Epic. Okay, guys, too much for today. We continue Wednesday. We finish the review package. I don't know. December 5th, you submit both. You submit the test online and submit by email the written test to me. Using always a school email. Because you're using external email, there are a possibility that the system send to the junk box. So I never see it. So I claim you, what happened with your test? We are doing the test for, you know this problem, right? Okay, guys. See you Wednesday. Bye-bye. Have a nice day.